Hello, everyone, and thank you for joining us for the latest webinar from ATA Engineering. My name is Jonathan Hill. Normally, I'm coming to you from our Northern Virginia office, and I'm really excited to turn things over to Tommy in our San Diego headquarters in just a second to give us just a closer overview of Nastran mass checks, some best practices, and why we should really be doing mass checks as part of our standard model checking procedures. Before we get that far, I do have a couple quick notes to share with you. The first is that today's webinar is being recorded and should be available on both our software website and our YouTube channel, either this afternoon or tomorrow. So I definitely invite you to keep an eye out for that. If you want to rewatch it, share it with a colleague or anything like that. In addition, everyone's been muted for now, and that's just so that we don't have any interruptions during the presentation. But I invite you to stick around until the end of the presentation because we're going to have a live Q&A session, and you'll be able to unmute yourself and ask questions at that time. You can also ask questions through the chat at any time during the presentation. Just keep in mind that we'll probably wait to come back to those questions until the very end as well. And finally, I'd like to give just a super brief intro to ATA for those of you who might be joining us for the first time now. So ATA is really excited to provide high value engineering services where we have expertise in design, analysis, and test. And we're really passionate about helping our customers overcome their most difficult product design challenges across a wide range of industries, just some of which are shown here. In addition, we're able to leverage that experience and that expertise through our role as a partner and value-added reseller for Siemens Digital Industries software. In that capacity, we offer training, free resources, and hotline support for a variety of Siemens tools, including Simcenter Nastran, Simcenter 3D, and Femap, which we'll be discussing in greater detail later today, but also some other really powerful tools like Star CCM Plus and NXCAD. We host a technical support hotline, and that runs from the beginning of the day on the East Coast until the end of the day on the West Coast, and that's actually staffed by our own technical engineers who are using these products every day for our services work. And then finally, I always like to point out that we actually develop the official Simcenter Nastran training materials for Siemens, and we're the preferred training provider of Simcenter Nastran in North America. Finally, we've been recognized with validated expertise by Siemens for Femap, Star CCM Plus, and Simcenter 3D. And then my last note here before turning things over to Tommy is just to invite you to check out our software website after today's presentation. We have a lot of really cool stuff going on there, including product information and calendars where you can stay up to date on our upcoming training classes and our other upcoming webinars. In addition, I always have to mention that my favorite part is the free resources. And those resources range from white papers and APIs to tutorials and other on-demand webinars similar to this. And probably the best part about that content is that it's generated specifically for the users that we're in touch with based on the needs that we hear. So my final point here is going to be that if you have a future resource topic or a future webinar topic, I'd definitely love to hear that. So feel free to reach out to me or anyone here on the ATA team to let us know the best way that we can be supporting you and your engineer team. With that, I'd like to go ahead and turn things over to Tommy for our main presentation today.
Yeah, thanks, Jonathan. So yeah, just go ahead and dive into this. So what's the motivation? Why do we want to check mass and weight? So there's two different things. There's mass checks and there's weight checks. So mass checks are the process of making sure that the mass of each component in your model matches some specified value and adjusting your finite element model as needed. And this is important, especially for dynamic analysis. Or in static analysis where you have load cases that are acceleration loads, because in those cases, you need to have the correct mass in order to accurately predict results. And weight check is a Nastran tool that basically you run a simulation. If you have a weight check on, it'll print out various mass and inertial properties for the different degrees of freedom sets, and we'll go into all this in more detail. But basically, this tool lets give you some insight into other modeling errors, such as connections between parts, and help you check that your units are correct. So this is a good way to check your model to make sure it's correct. So I guess the very first thing I'll talk about is in Femap, it's easy to check the mass of your FEA model. Just go to Tools, Mass Properties, Mesh Properties, and that and select all the elements you want to measure the mass for, and then it'll print out this information to the message window for the elements you selected, and it'll give you things like the structural mass, non-structural mass, total mass, the CG, and then and also the inertial properties too. And then in Simcenter 3D, there's a very similar command. If you go to Home ribbon, more solid properties check, and select all elements, turn on all the options there, then you'll get a similar message window like Femap telling you the mass, volume, CG, inertia, and so on. But just a quick note is that if you're using Con M1 elements in your model, don't include these in the preprocessor check, because these Con M1 elements are, the mass is dependent on direction. So NX actually excludes these from the solid properties check, but WEIGHTCHECK will have those. So just be aware if you're using that element type, just be aware of which type of mass you're checking. So how much mass checking should we do? At the very least, it's recommended to list the mass of your entire FEA model and verify against some expected mass. Like if you have a master equipment list or a MEL with total mass of your model, the actual system, it's good to verify that your finite element model mass matches the expected real life mass of your system. But ideally, you go in deeper and don't just do the whole model, but also each component or subsystem group, verify the mass of each of those components of your model and compare the mass and the CG to your expected value. And one way that makes this easier is that we have an Femap API on our website, which does this a lot more efficiently. So instead of doing one by one, you can basically select all, if you have groups already set up in your model that represent different components, you can run this API and it'll give you an Excel spreadsheet that lists, among other things, the mass, CG, et cetera, for each group that you have. So different ways to do mass matching. So if your finite element model mass doesn't match your real life mass, some things you could do. Well, first you want to make sure that your material properties are correct and you didn't forget to mesh anything. But if check all those things and that's all in line, you might want to adjust the density of the material or add non-structural mass to the mesh. And just be careful. Ideally, you do one of these things or the other, but if you do both of them, it could get confusing. So just take some bookkeeping and just organization to make sure that your mass matching and things are just consistent and that you're following what's going on with your system. So then WEIGHTCHECK, this is a little bit different. So how to set this up in Femap. So this is actually a way thing we set up for Nastran simulation. So in Femap, if you go to the Analysis Set Manager, and then under Options, Model Check, you go to that, then it'll open this right-hand dialog box, and there's two different things, the WEIGHTCHECK and ground check. There's a WEIGHTCHECK with the options shown. And so ideally, you should do both WEIGHTCHECK and ground check. We already had a webinar on ground check that you can check out, but today we'll focus on WEIGHTCHECK. So this shows you the different inputs like the DOF sets, the CGI option, and reference nodes and units. And I'll get into more detail on this later, just showing you how you can set up this in preprocessor in Femap. And then Simcenter, again, similar. Here you set it up in the solution window, and this is under the case control rigid body checks section. And in that second red box at the right, that you see the green arrow with the button next to that, that second to last button on the right, click on that, and then that'll create a new rigid body checks modeling object. And here, again, you can set up both grounding and mass reduction, which is WEIGHTCHECK here. And then it looks like the Femap window with just different formatting, but you can choose how to output it, and choose the CGI options and units, and then also which DOF sets. And I'll get into that in more detail later too. And also reference node. So to dive into what actually goes on in the weight check, so here's what the weight check syntax looks like in the Nastran input file. So if you set this up in Femap or in NX, you'll get this in your input deck, or you could even set it up directly in the deck. Basically, weight check reports the mass properties of a part, including the mass, moment of inertia, and centering mass. So the first input, the print statement, that just tells Nastran to output the weight check results to the FO6 file. So that's a good idea to have that set to print. The set, you can have all your DOF sets activated for this, and I'll go into this, what each set is next slide, but at the very least, you want to check your G, N, and A sets, and you want to make sure that those the mass is the same across those sets. And then the reference location is important because the weight check depends on that location. If you don't specify a grid or a node, it'll just use the origin of the Nastran corner system. But if your origin is really far from the actual center of the mesh, then you'll want to pick a node that's closer to the CG and use that as the reference point. CGI, this requests center of gravity and inertia. If you put no, it'll only print it for the G set. And then the last option is telling Nastran whether to output results in mass units or weight units. So it's good to be careful and make sure you know which one you picked, because then in the FO6 file you'll know what you're looking at, mass or weight. So to go into more detail about the Nastran sets, so the response of a finite element model is defined in terms of DOF, or degrees of freedom. So there's 6 DOF per grid, and 1 per S point, or scalar points, or these extra points. But basically, just keep in mind these sets. All the DOF are placed in the sets in Nastran. So the G set is all DOFs minus E points. The M is all dependent DOF, so RBEs and multi-point constraints. The N set is independent DOF, so this is all the G set minus the M set essentially. And then those are the other sets, the S set, F set. I won't go into detail too much, but just how to have this here as a reference for you, because there's a lot of different sets going on, and just to make sure you have an idea of what these are and which ones are important. So to go into, so let's say you set up your weight check, and then you ran something like a free modes run or some kind of model check run, unit gravities, and then you get this output from the weight check in the FO6 file. So if you scroll down your FO6 file, it should look something like this. And so a lot of numbers going on here. Hopefully this slide will make it a little bit clear what's going on. But the first thing to look at is this 3x3 matrix that lists in the red box, that lists the mass on the main diagonal. And so those 3 values, 4.38, E-3, are all the same. So those are the mass. These green matrices are used to calculate center of gravity based on the reference point. And then the blue matrix is the inertia properties with respect to the reference point. And then again, the mass values are repeated in this next section in red again. So those 3 values are the same as the ones at the top. And then unless you have some kind of atypical mass elements like CONM1, then otherwise these 3 values should be the same if you don't, unless you have some kind of directionality in your mass. And then the yellow box, this matrix tells you the coordinates of the CG about each axis, and the diagonal element, numbers are all 0. And with no atypical properties, you would expect 2 of the values in each column to be identical, giving you what the CG location is in that direction. And then again, here at the bottom is the inertia properties repeated in blue, including the principal inertias and the principal axes. So just to go into more detail about more about the weight check output. So again, the top left, the mass, then those blue matrices are the CG. and the red is inertia, but just kind of see how things are calculated. So on the top right, that matrix kind of tells you what each value is in that blue matrix, and it's being multiplied by the mass. So essentially, take that blue matrix and multiply it by the mass, or the blue matrix is the mass multiplied by those that matrix which has the CG values in it. So if you divide the blue matrix by mass, you get CG coordinates. And this is again where you need to be careful if you're using weight or mass to just make sure you know how you set it up, so you know what these numbers mean and so you're not confused. So it is a little bit tricky. So what to look for in these output? Like how do you know if your weight check makes sense and if it's correct, or if you need to revisit your model? So check if the mass matches your expectations. So this will help you with all your material properties. Make sure your densities and stuff are all correct and that your units are what you intended. Compare the weight check values for mass to the preprocessor mass. Those should ideally be the same. And if not, you should understand why they are not the same. Compare the mass to the mass based on the CAD volume. So if you have the assembly model geometry of your system that you're modeling, good to measure the volume of that, those solid bodies, and then use the material density to see what that mass should be and make sure that's very close, if not equal, to your finite element model mesh. And just a note about this weight mass parameter. If you're using the weight mass parameter, it's good to understand what exactly it does. It can be a little tricky. I guess it's easier to just to not use it, but if you are using it, again, make sure you understand what that does and make sure you know whether or not you're printing out masses or weights. And then again, this is the last input in the weight check card in Nastran, mass or weight. And if you're using DMIG mass matrices, the mass from the weight check will not match the mass in your preprocessor. So just be aware of that. And then just still compare the mass to preprocessor to verify it matches what you think it should, but just kind of a heads up, DMIGs will do that. And then across different sets, so check the mass between sets to make sure they're the same across sets, like what I mentioned before, the G, the N, and the A. If they're not the same across those sets, that probably means there's something wrong with the model, because otherwise those should be equal. So if you're noticing that those masses are different between sets, look at some other model checks, like grounding might be a good thing to look at again. Make sure you know exactly what's being restrained in your model, what your boundary conditions are, and make sure those are correct. And then review all your auto SBCs as well. And then here's some things that might be the culprit as to why the mass change across the different DOF sets in your weight check output. So if you have mass on a boundary condition, such as like a lump mass on an SBC, that's something to note, just to be aware of. And then mass readings that have been auto SBC'd. And then again, grounding. You should do grounding checks in addition anyway, but if you maybe if you notice in your weight check you get this different mass in different sets, you might want to double check your grounding or rerun that to make sure you don't have grounding in your model. And again, you can refer to our grounding presentation from a little while ago for more information on that. Lump mass in the O set, this is a model reduction, so that would be another thing to double check if you're getting those inconsistencies. And then this is a kind of example case scenario, something that was an interesting study or interesting observation was in a previous example, we had there's a large assembly model where one component was switched out with the lump mass. And the original model had these small lump mass elements, and those were not reconnected to the main rest of the model. So these disconnected elements were auto SBC by Nastran. And then when the weight check was run, auto SBCs were added in between the N set and check and the A set check. The model mass was different between those two sets, and that was actually a good alert that tells us that there was a disconnection in the model. So usually Catching these kind of things are good because the weight check is not just to make sure weight is correct, but also to make sure you don't have any disconnections or other anomalies in your model that need to be fixed. So just a good lesson learned that this is a good check to do for various reasons. And then just to kind of, oh, and then one last thing, checking mass. Another way to check mass is using reaction forces. So if you use acceleration loads, it's good to look at the net reaction forces and compare the sum of those reaction forces to the Fem total mass times applied acceleration, or in other words, F equals ma. And if you're not getting F equals ma, you want to double check your model to make sure there's something wrong with it. And the Nastran WEIGHTCHECK, I guess, is preferred, but it doesn't hurt to do both, especially if you're using another solver like ANSYS or something instead of Nastran that might not have the exact same weight check tool. It's good to just double check or triple check that you're getting what you expect from your model. And that's all I had for today.
And while those questions are coming in, again, thanks, Tommy, for going through that, how to check mass in the preprocessor, how to check mass with Nastran, as well as unit mass checks, just to kind of verify that you know the mass that's represented in your model, and you know that the units you're using are correct and match up, and so just really good stuff. So does anyone have any questions at this time? And certainly if you're rewatching that or you're watching the recording and you have questions, still feel free to reach out to us. We'll have the slides up, and our contact info is at the end of that as well. So we did have, Tommy, I don't know if you can see the chat, but we did get a question. If you have any recommendations when using weight mass. So I guess when would you want to use weight mass, and sort of recommendations for just things to keep in mind when using weight mass?
Yeah, so it's a good question. I'll hop back to that slide again. I don't have a whole lot of experience myself using weight mass, but there was some information, I guess, in the notes section of this PowerPoint. So just about the weight, a little more about the weight mass. This parameter is a little confusing. It's easy to mess up. It's, I guess it's easier to not use it at all, but if you do use it, you should also check the mass using reaction forces. So I guess, why is it confusing? If you use parameter weight mass, and this is all in the PowerPoint, in the notes section below the slides, so it's there for you, but I'll go into detail. If you use the weight mass parameter, then all mass properties, including lump masses per unit length, non-structural mass, etc., will be scaled by gravity to become weight units, except for the DMIG, which does not scale. But if you use a parameter, this parameter weight mass, make sure you set the parameter to be 1/g, where g is the actual gravity value in your model. If you use something else, you're going to have error. So yeah, if you use that parameter, WEIGHTCHECK reports weight by default. So just, I guess, just to reiterate, make sure you know whether or not your models or your WEIGHTCHECK is in weight or mass. But yeah, just that's pretty much all there is. Just, I guess, be aware of how it works and make sure that you know what if it's mass or weight, and then make sure you use that 1/g scale factor if you're using it.
Cool, thank you, Tommy. Are there any other questions out there? Otherwise, we can wrap up for today, I think. Again, we appreciate you attending our webinar today. Thanks again, Tommy, for leading the conversation. And we hope to see you back for our future webinars. Have a great afternoon, everyone. Bye.